Okay, this is the Unit 7 mastery project, going over the progress check FRQ number 1. So it asks, in their physics classroom, students want to hang a heavy sign of mass m and length L as shown in the figure above. The sign makes an angle theta with the wall. Without any support, the sign would rotate clockwise, while its pivot would remain connected to the wall. The students can connect one support cable vertically from one of the hooks above the sign, as indicated by the dotted lines in the diagram. Rank the 3 hook locations according to the amount of tension the support cable would experience if the students decide to support the sign from that location. Use 1 for the least tension and 3 for the greatest tension. So it asks in ABC, and to rank them from least to greatest. So it's going to be okay, well, first at position C, it'll have the least amount of torque or tension. The string will have the least amount of tension, because torque is equal to force times perpendicular force times distance. And so since the distance is increased, the force needed to support the same amount of torque will be a lot less. So let's say the distance from the pivot to C is 10. Let's say the torque is 20. Then that means the force needed will only be 2. But let's say for at position A, it's only the distance is only 2 meters away from the pivot, so that means you would need a force of 10 to support the same torque as 20 of 20. So that's why A would need the most amount of tension force. Would need the most amount of force due to tension. And then B is right in the middle, so it would need it would be a little bit more away from the pivot, but not as much as C, so it would need the second most amount of force due to tension. So it would be the second most. Okay. Let's see part B. Students want to hang the sign with a cable, but the cable breaks and the sign rotates clockwise. The diagram below shows the sign at 3 different times that it is rotating. Indicate at which time, if any, the angular acceleration alpha of the sign is greatest, or whether it is the same at all 3 times. So the sign kind of looks like this. At T1, T2, and T3. And it asks you to rank T1, T2, and T3 for the how big the angular acceleration is. Okay, so T1, it's gonna be the greatest because, or actually, let's see, angular acceleration. See, T1 is going to have the most amount of angular acceleration, and so because it comes from rest, from being hung up, so from rest to whatever kind of amount it's being dropped from the pivot, or like sliding from the pivot in this motion, it's going to have the most, so 1. And then T2 is just going to be moving at a pretty much steady acceleration, so it's going to be the least amount here, and then t3 is when it's going to slow down and stop. So when it stops, when it goes from some velocity to 0, that's going to be more than just going from some velocity to some velocity most of the time. So that's why t3 will be 2. Okay, and part 2 of B show that alpha can be modeled with 3g sine theta over 2L. The rotational inertia of the sine is I equals 1/3 ml squared. So you can use the equation. Let's see. So you need to find an equation with I and alpha, and that is going to be the sum of the torques, and the torque is also equal to force times perpendicular distance, or perpendicular force times distance. So you can see in the question that it uses it somehow like cancels the L's from each other, and it has force due to gravity, and it has distance. So you're gonna have that equals to force times distance. So Fg times 2 sine theta, and you have to break it up into sine theta. Okay, so then you do, let's see, then you try and simplify the 2. So 1/3 ml squared. Let's see, this is actually mg because of force of gravity. So these cancel. And then one of these can cancel with that. So 1/3 L is equal to G. L 1/3. There should be a alpha there. Equals to G 1/2 sine theta. And this is pretty much equal to 1/3 equals G sine theta. Over 2, you're solving for alpha here. So you get G sine theta over 2L times 3 equals to alpha. You get that. And yeah, that's the same answer that they got. So yeah, that works. Alpha can be isolated into that. So part C, the students want to describe the angular velocity omega of the sine as it rotates, and they propose the following equation: 3g sine theta over 2 ls times t is equal to omega for angular velocity. So you do omega as a function of time is equal to 3g sine theta over 2 ls times t. So angular velocity. So this doesn't really make sense, because what this is telling you is as time gets bigger, angular velocity will also get bigger, and that's not really going to happen. The angular velocity is going to have to slow down, since it's a sine moving like down to where it stops. So we can write that this equation does not make sense because the angular velocity will eventually have to slow down. Okay. Let's see, in part D it says, for students independently derive equations and propose them to describe the motion of the sign. Which equation best matches the data collected? So the graph shows that it starts at like 5.5-ish for the y on the y-axis. So based off that, we can see that it's probably not going to be a sine graph because sine starts at 0. So we can eliminate the bottom two answers. And then the only difference is G on the bottom or on top? And is L on the bottom or the top? And with our equation from this one, we can see that G is on the top and L is on the bottom. So we can assume that it's going to be the first one.